Earlier today, my codebase shipped a feature, planned, written, tested, and opened a pull request, and I didn't type a single line of it. But don't get the wrong idea. I wasn't gone. I was working the entire time, just not directly on the code, but rather the system that generated the code. Here's a shift almost nobody's talking about. You should stop working directly on the code, and you should start working on the harness system that outputs the code. And that turns out to be the most important work a developer can do, because improving the harness system doesn't just help with one feature. It makes every future feature better forever. This is Context Specs, an open source harness system driven by Spec Driven Development. And yes, it will build features on its own, but the autonomy is not the headline. The headline is where developers' attention gets to go instead. You move up a level. You're not down in the code anymore. You're up in the system that produces the code. Karpathy put it perfectly. You can outsource your thinking, but you can't outsource your understanding. The harness took the thinking you can hand off, the coding syntax, the tasks with high levels of verifiability, but the understanding, that is this feature even worth building? Is this architecture still serving the product? Is this the right abstraction? These judgment calls, that's what you, the developer, own and should encode into the system. Hi, my name is Rico, and I'm a tech lead. I'm the main contributor of Context Specs, backed by Capital One. Before I show you anything, here's Context Specs in one frame. It runs on a simple 3-step loop. 1. Intent in, result out. You give intent, and the harness runs the spec-driven development process on its own and hands you back a predictable result. 2. Understand the result deeply. You review that result and the harness's own work to find out what's worth improving. 3. The harness learns forever. You encode what you learn back into the system, so it's enforced on every feature from there on, and it gets a little smarter every single time you use it. Hold on to these 3. Everything else hangs off of them. Step 1, intent in, result out. Let's see how it's done. You should start with creating the harness itself, because if you don't trust it, none of the rest works. Next, start the harness and let it run autonomously. The thing most people get wrong about autonomous agents is they treat it like a slot machine. They pull a lever, pray, see what falls out. This is the opposite of that. The harness is a system with a defined input and a defined output. You give it one thing, intent, a clear description of the feature, and an end-to-end test that codifies the definition of done. That's the input contract for Context Specs. And the output is just as defined. The harness runs the spec-driven development pipeline. It plans, it validates the plans with multiple agents. It implements, it tests itself as it goes. Finally, it hands you back exactly one of 2 things. Either a pull request that is ready for you to review and merge, or a stuck. And a stuck is the part I love the most, because it's the harness being honest. When it genuinely cannot make progress, it doesn't fake a green check and hand you back broken code. It stops and tells you exactly where it got stuck and the breadcrumbs to figure out why, the Claude session IDs. The predictability is the whole foundation. Intent in, reviewable PR, or an honest, I got stuck. Here are the Claude sessions that need debugging. 2 outcomes, no mystery. Therefore, you can actually build on top of it, the same way you build on any reliable machine, because you always know the shape of what's coming back. So the harness gives you a predictable result. That alone is useful, but if all you ever did is glance at a PR and click merge, you're leaving the entire point on the table, because that result isn't just a feature. It's a report card on your system, and reading it the right way is the single highest leverage you can do all week. Let me show you what I mean. Step 2, understand the result deeply. When the pull request comes back, the naive approach is to judge the feature. Is it good? Merge it. Is it bad? Fix it, move on. But that is still thinking like someone who directly works on code. You don't do that anymore. Instead, you read every result as a feedback about your system. So I go deep on two things. First, I review the PR to genuinely understand it. Run it locally, walk through the edge cases, judge the things no test can. And understanding it that deeply lets me do something a green check never can. Read between the lines of the PRD. What was the feature really reaching for? Not just what the words asked for. Did the output meet that? Because here's actually what happens in practice. A PR can pass every test and still quietly miss the point. Only real understanding catches it. And the moment it does, I'm not looking at a bad feature. I'm looking at a gap in my system. The second thing, the one almost nobody does, read the Claude sessions, the actual transcripts of how the harness built the feature. I'm debugging Claude code itself. I'm looking for the moment it guessed, the moment it rederives something it had already known, the moment it followed a stale note and went the wrong way. Every one of those, and every gap I caught reading between the lines of that PR is the same thing. A place in my harness system failed to tell my agent what it needed. Here's why this is the whole game. If you fix the code, you fix one feature. If you fix the system, the gap that produced it, you fix the entire class. Every future feature that would have hit the same gap now sails right past it. So the hour you spend understanding a result and finding the context gap is worth more than the feature itself. It pays out on every future feature you build after it. That's what operating on the system actually means. You're not just maintaining code, you're upgrading the machine that writes it. And understanding is how you find what to upgrade. So, understanding shows you the gap. Now you close it, and you have two instruments for that. One bends, one doesn't. Knowing which a given gap calls for is a real skill. Step 3, the harness learns forever, and this is the one that compounds. The first instrument is prose, the harness's long-term memory. When a gap is missing a fact, a fuzzy definition of done, a pattern this codebase should prefer, you write it down where the next agent will read it. Mostly, that knowledge is specific to your project. How the codebase is built, the works of an internal library it leans on, and it grows as the project does. The generic steps, the harness follows to plan, verify, you rarely touch. The project-specific knowledge, that keeps evolving. Prose is broad and cheap, but it's still advice. Context the agent reads, interprets, and mostly honors. For a lot of gaps, mostly is fine. For some, it isn't. And that's where the second instrument comes in, and where the highest order thinking you do lives. Here's the thing that never went away, and never will. The architectural level judgment. What patterns must this codebase follow? What invariants must it protect no matter what? The machine cannot do this for you. It's great at local implementation, but weak at holding global structure together over time. And prose won't save you here, because prose is a suggestion, and the structure dies by 1,000 suggestions quietly not being followed. So you make it unbreakable. You encode it as a lint, a check that runs before a PR is even open. A structural rule. This layer never imports that one. Every log must go through this logger. Stops being tribal knowledge and becomes a wall the agent literally cannot ship past. And the error message this lint gives back tells it how to fix itself. The wall teaches instead of just blocking. Fewer things earn this. Only what you can mechanically check, which is exactly why a rule usually starts as prose and then graduates to a lint once you have watched it cross it one too many times. So that's the whole move. Prose carried the knowledge, lints carried the structure that can't be allowed to bend. You're not hoping the agent matches your standards. You're making the ones that matter most physically unbreakable for the agent and honestly for you too. And this is why the system is an asset that appreciates. A normal code base decays. Every feature is a chance for someone to quietly violate a pattern nobody wrote down. But every fact you log and every lint you encode protects every future feature that comes after it. Automatically, forever. You stop being a developer who writes code. You become an architect of a system that builds to your standards on its own. That higher order thinking isn't going anywhere. It just became the entire job. So here's the custom harness system, the whole thing in one picture. You give intent. The harness runs a predictable system and hands you back a reviewable PR or an honest duck. You review the PR and the machine's own sessions to find out where your system fell short. And you encode what you learn back into the harness. So every future feature inherits it. The machine does the typing. You build the machine. Remember that merge pull request from the start? The one that I didn't write? That never was the achievement. The achievement is the system behind it, getting a little smarter every time I use it. Context Specs is open source and ready to help you build your custom harness. If you like this video, do me a favor, go star the repo. It genuinely helps more builders find it. The link's in the description. And if you want to try it right now, the Getting Started Guide is a simple setup, and you can start building your own custom harness system instead of just writing the code. See you in the next one.